Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
So there's this big interest in AI in general with this concept of AGI, which people seem to kind of take their own interpretations for. And I have to be honest, I've always found the whole thing a little bit nebulous and kind of dystopian and strange, this idea that we can reach some kind of tipping point of intelligence. It doesn't really kind of vibe with me. And there's been some coverage in the last week or two regarding someone described as the forefather of AI, saying that LLMs will not get us to, they're a waste of time, they're a dead end, and we need to think about world models. All this is very kind of abstract to me. And I see building with AI every day. I see the limits of LLMs very clearly. To me, the biggest challenge actually is context. It's an area that I think makes or breaks a lot of AI workflows. But I have to say, would be very wary to dismiss LLMs out of hand, because I think they've generated so much fantastic technology in such a short span of time that they deserve respect, as it were. So I'm curious about this argument from a, let's say, dispassionate position regarding this kind of controversy around LLMs. Is it really something that's inherently limited? And taking one or two sides of the argument, putting them to the side, what are the kind of broader thoughts out there in the AI community regarding what the kind of future evolution is, and what is the future evolution? If we put the hype about AGI to the side for a second, and more maybe mature parts of the discourse, what are people seeing as the most likely path to stable growth? Not necessarily, explosive, this has to happen soon, but the people who are kind of taking a more long-term steady view of the evolution of AI over time. Is it kind of all predicated on quantum, or do they also subscribe to this view that LLMs are just kind of a entryway as such? What does that argument look like at the moment?
Welcome back to AI Conversations. Today we're diving into a topic that's been buzzing around the AI community, something that feels both incredibly exciting and, if I'm honest, a little bit nebulous. We're talking about AGI, artificial general intelligence, and the intense debate about how we even get there, or if we're on the right path at all.
Indeed, Corn. It's a fundamental question that's currently shaping research directions, investment, and ultimately the kind of AI systems we'll see emerge in the coming decades. What most people might not realize is that beneath the surface of all the hype, there's a serious academic disagreement brewing about the very foundations of AI.
Absolutely. I mean, for me, when I hear AGI, I immediately conjure images of sci-fi robots, thinking like humans, maybe even feeling like us. But then you hear prominent figures in the field, literally forefathers of AI, saying things that completely challenge our current trajectory, especially when it comes to the large language models everyone's using. They're calling them a dead end. It just leaves you wondering, where are we actually going with all this?
Precisely. We're going to unpack that dead-end argument, explore the concept of AGI beyond the cinematic fantasy, and delve into this idea of world models that some believe is the true path forward. We'll look at the strengths and limitations of current LLMs and try to find a dispassionate view of what the mature discourse within the AI community suggests for the future of stable, impactful AI development.
So, we're cutting through the hype and getting to the substance of what true progress in AI might look like. If you're building with AI, working alongside it, or just curious about what's next, this conversation is going to be crucial for understanding the landscape.
Let's begin by defining our terms. AGI, or artificial general intelligence, is generally understood as AI exhibiting human-level cognitive abilities across a wide range of tasks, not just specialized ones. Think problem solving, learning from experience, understanding complex ideas, adapting to new situations, and applying knowledge in diverse domains. It's the difference between a chess AI that excels only at chess and an AI that could learn chess, then how to bake a cake, then how to write a novel, all with similar proficiency.
Okay, so not just narrow intelligence, but broad, adaptable intelligence. But you mentioned it's nebulous, and I feel that. Is it because we don't even fully understand human intelligence? So how can we define human level for a machine?
That's a core part of the nebulousness, Korn. We lack a universally agreed upon metric or a clear definition of what human level even means quantitatively. Is it passing a Turing test? Mastering every subject in a university curriculum? Displaying common sense in novel situations? Each of these present significant measurement challenges. This ambiguity often leads to wildly different interpretations and timelines for AGI's arrival, from imminent to centuries away. And, of course, it fuels those dystopian fears you mentioned, because an ill-defined goal can easily become a scary one.
Right, so we're aiming for a target we can't quite see clearly. Now, let's talk about this dead-end argument. Recently, there's been a lot of discussion around some AI pioneers, like Geoffrey Hinton, often called the godfather of deep learning, suggesting that large language models, or LLMs, might not be the direct path to AGI. Can you elaborate on why they believe this? What's the fundamental critique?
Absolutely. The central critique, originating from influential figures like Hinton and Yann LeCun, is that LLMs, for all their impressive capabilities, fundamentally lack a world model, an internal causal understanding of how the world works. They are incredibly sophisticated statistical pattern matchers. They excel at predicting the next token based on vast amounts of text data. This allows them to generate coherent prose, answer questions, and even write code. However, critics argue this doesn't equate to genuine understanding or intelligence.
So, it's like they're phenomenal at regurgitating and remixing information, but they don't truly know what they're saying. Like a brilliant actor who can perfectly deliver a line about quantum physics, but has no grasp of the underlying science.
That's a very apt analogy, Korn. Consider this. LLMs can hallucinate, generating factually incorrect or nonsensical information with high confidence. This happens precisely because they prioritize plausible-sounding sequences of tokens over truth or logical consistency. They don't have a built-in mechanism to verify facts against a consistent internal model of reality. Furthermore, they struggle with common-sense reasoning, abstract planning, and genuine long-term memory or self-correction in a truly dynamic environment. Their understanding is shallow, lacking the grounded context that humans naturally possess.
Okay, that makes sense. We see those hallucinations all the time, and it's a big limitation. So, if LLMs are a dead end, what's the proposed alternative? This idea of world models, what are they, and why are they considered so crucial for advancing AI beyond our current capabilities?
World models are essentially internal simulations or representations that an AI system builds of its environment, including objects, their properties, how they interact, the laws of physics, and causal relationships. Think of it as the AI creating its own miniature universe within itself, allowing it to predict future states, understand consequences, and plan actions in a much more sophisticated way than merely predicting the next word.
So, instead of just seeing individual pieces of text, a world model helps the AI understand the relationships between those pieces and how they fit into a larger, coherent reality.
Precisely. Imagine a child learning to stack blocks. They don't just learn block A goes on block B. They learn about gravity, balance, the properties of the blocks themselves. That's building a world model. For an AI, this means it could simulate potential actions, foresee their outcomes, and learn from those simulations without needing to interact with the real world constantly, which is both expensive and time-consuming. Yann LeCun, for instance, postulates that true intelligence requires such models to learn massive amounts of background knowledge about the world through observation, without explicit supervision. He envisions models that can answer what if questions, predict future events, and truly understand cause and effect.
That sounds incredibly powerful, and quite different from what LLMs are doing right now. Are there any existing AI systems that incorporate elements of world models, even rudimentary ones?
Absolutely. We see foundational elements in areas like reinforcement learning for robotics. For example, a robot learning to navigate a complex environment might build an internal map and a prediction model of how its actions affect its position and the environment. AlphaGo, DeepMind's Go AI, effectively builds a sophisticated world model of the game of Go, allowing it to simulate millions of future moves and evaluate positions, leading to superhuman performance. It's not a general world model of our physical reality, but it demonstrates the power of internal predictive models. Current research is actively exploring how to integrate this kind of learning.
Okay, so we have LLMs, which are fantastic at language but lack deeper understanding. And then we have world models, which promise the deeper understanding but are currently more confined to specific domains. It feels like there's a tension there. But LLMs have been incredibly useful. I use them every day. They've transformed so many industries in such a short time. Are they truly a dead end? Or is that perhaps an overly strong statement?
That's a crucial point, Corn, and one that sparks a lot of debate. While figures like Hinton and LeCun point out fundamental limitations for AGI, few would argue that LLMs are without immense value. They have democratized access to advanced language capabilities, accelerating coding, content creation, research, and data analysis at an unprecedented scale. Their ability to synthesize information, summarize complex documents, translate languages, and even engage in basic reasoning tasks has been nothing short of revolutionary.
Right, the sheer volume of tasks they can assist with is staggering. It almost feels like they're already performing at a general level for a huge swath of human cognitive activity, at least in the language domain.
They are. The term emergent properties is often used to describe how LLMs developed capabilities that even their creators didn't explicitly program or anticipate, simply by scaling up data and parameters. However, their limitations, especially regarding persistent memory, true common sense, and causal reasoning, mean they require significant human oversight and grounding in real-world applications.
So, it's not really a dead end as much as it is potentially a component, or maybe even a stepping stone, rather than the final destination for AGI. It seems too valuable to just discard.
Precisely. The more nuanced view, and one gaining traction, is that LLMs are not this entire solution to AGI, but they are an incredibly powerful part of it. They could serve as the language faculty or the reasoning engine for symbolic manipulation within a larger hybrid architecture. Imagine an LLM acting as the communicator and knowledge retriever interfacing with a separate world model that handles planning, simulation, and understanding causality. This is where the concept of multimodal AI becomes relevant, combining LLMs with vision systems, robotics, and agents that can interact with and learn from their environment.
So, we're talking about a symphony of AI components rather than a single monolithic superbrain. An LLM might tell me how to build a birdhouse, but a world model would understand why certain joints are stronger or what happens if I use the wrong screw.
Exactly. Current research is already moving in this direction. We're seeing systems where LLMs are granted access to external tools, code interpreters, search engines, robotic actuators, even planning algorithms. The LLM then acts as a sophisticated coordinator, using its language understanding to decide which tool to use, feeding it relevant information, and interpreting the results. This moves beyond pure next token prediction towards goal-driven behavior within a broader environment. It's a pragmatic bridge between the current success of LLMs and the long-term goal of AI that genuinely understands and interacts with the world.
That's a much more optimistic and, frankly, practical outlook than just declaring LLMs a dead end. So, for our listeners, what are the practical takeaways here? If I'm a developer, a business leader, or just someone who uses these tools, what should I keep in mind about this ongoing debate?
For developers and researchers, the key takeaway is to embrace a multi-paradigm approach. Don't dismiss LLMs. They are incredibly potent for language-centric tasks, but understand their inherent limitations regarding truthfulness, common sense, and deep reasoning. Focus on how to ground LLMs by integrating them with external knowledge bases, sensory inputs, and especially mechanisms that allow them to build or interact with world models. Explore agentic AI, where LLMs act as the brain, coordinating actions within a simulated or real environment.
So don't just plug an LLM in and hope it's sentient. Give it context, tools, and a framework to operate within a simulated reality.
Precisely. For businesses, the implication is to leverage LLMs for what they excel at: content generation, customer service, data analysis, summarization, and initial ideation, but always with a robust human in-the-loop validation process. Don't expect them to magically solve complex, open-ended problems requiring deep, causal understanding without significant scaffolding. The future involves increasingly sophisticated AI assistants that augment human capabilities, not necessarily replace them outright, at least in the near term.
And for the everyday user like me, who just wants to understand the broader implications.
For the general public, it means being discerning about the claims made about AI. Understand that current LLMs are powerful tools, but they are not thinking in the human sense. Recognize their strengths and weaknesses, especially regarding factual accuracy and the absence of true understanding or consciousness. This debate highlights that AI research is dynamic, not monolithic, and there are many fascinating avenues being explored simultaneously.
That's really helpful to frame it that way. It moves us away from that nebulous, almost mystical view of AGI and towards a more grounded, evolutionary perspective. So, as we look to the future, what are the big questions that remain unanswered, and what predictions might you make about this debate going forward?
Looking ahead, the biggest unanswered question is how we scale the building of robust world models. Human infants learn about physics and causality through years of interaction with their environment. Replicating that kind of emergent learning and rich representation in an AI system is an enormous challenge. Will it come from massive unsupervised learning on video data, from simulated environments, or from completely novel architectures yet to be discovered?
That's a tough one. How do you even begin to simulate that level of complex, real-world interaction for an AI?
Exactly. My prediction, however, is that we will see increasing convergence. The dead-end argument for LLMs will soften as researchers demonstrate increasingly sophisticated hybrid architectures that pair powerful language models with structured knowledge, sensory data, and nascent world models. The idea of LLMs as an entryway will evolve into LLMs as a critical component in a more complex, multimodal system capable of greater adaptability and understanding. We'll likely see less of an either-or debate and more of a how-to-combine discourse.
So the future of AI isn't about one single path, but rather a complex, interconnected highway system. It feels like we're just at the beginning of understanding what's truly possible. This has been an incredibly insightful discussion, Herman. Thank you for shedding light on such a nuanced and important topic.
My pleasure, Korn. It's vital that we continue to explore these questions thoughtfully and with an open mind. The future of AI is still very much being written.
And we'll be here to discuss every new chapter. Join us next time on AI Conversations as we continue to explore the fascinating world of artificial intelligence. Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.